Hi. Thanks for joining us with Davis Aviation. Hey, quiet on the set over there! Hey, we're trying to work here, people. I can't work under these conditions. I need 5 minutes. Hey, this is Carl Davis with Davis Aviation here. We're about to do a Borescope on a PT6A-135 Alpha. We're not going to go over really the modules or anything to do with the PT6 more other than just focusing on a Borescope inspection. Do not try this at home. Only a licensed and trained professional should be doing this. And we've called everyone we know, and this is the best we got. So make sure you have the appropriate data from the manufacturer when you're doing the inspection, and a appropriately rated licensed aircraft and power plant mechanic. There is in the maintenance manual, PT6 maintenance manual, a Borescope inspection guide. All we have here for reference only. Booklet here is current and up to date. Chapter 72 of the PT6 maintenance manual. It's got an explanation of a Borescope inspection. We're using the GE XL View for our Borescope videoscope. It's a good high quality Borescope. You can get far less expensive equipment. We found that this one served us really well. It has a lot of capabilities that others don't. It's on the higher end of the pricing point of the market. As you can see, some of the features I'm going to show you that it can do, to me they're well worth the extra. So we'll go over some of the tools we're going to have for getting the Borescope done. Handy dandy carrying case, yes. The Pratt & Whitney approved tool and Borescope insertion tool. There's 3 different types of insertion tubes for a PT6. All of them end in either -200, 400, or 600. -200 basically is for small motors, 400 is medium, 600 is large. And this is just to get us the right angle into the hot section. Now this is just for a little tapping to overcome an O-ring, screwdriver for cowlings. This is a better tool for removing the transfer tube. A pair of needle nose pliers do the same trick. Just be careful not to score the transfer tube when you're doing it. Set of sockets, and of course the XL View Borescope. Okay, GE XL View. Not going to spend a whole heck of a lot of time on all the features, but just a quick overview. You have the ability to input a headset or a VGA to a bigger screen if you wanted to. You have a USB on the side to capture video and still shots. This Borescope's articulation of the tip is really what is the reason we went with this Borescope. That and the diameter of the probe itself. It can actually go through the inlet screen without having to remove the inlet screen, which dramatically reduces the time that it takes to do the inspection. Battery life, I've really not had any issues with. We Borescoped 8 engines on 1 battery charge. Articulation is done with this little joystick. You can lock it when you get it into a certain position. Needle nose pliers, removal of safety wire. Remove safety wire and 2 nozzles because you have to. You have this bracket here that keeps the transfer tubes in place. You actually have to move the transfer tubes into the adapter for removal. 1/4 inch 12 point. I normally have people that do this for me. I'm just here for the big stuff. Like the doctor, you know, the nurses do all the work and then he just comes in and says, alright, sew them up, they look good. I have people that unbutton my engines for me so I don't have to get my hands dirty. But for the sake of, you know, Hollywood, I'm here to appease, here to entertain, so you're welcome. It's prudent to reinstall bolts so that when you move the transfer tubes with your calibrated persuasion device, aka a hammer, you are pushing against these bolts instead of with the actual fuel nozzle sheath, because that's the only thing that you're pushing against otherwise. Little tap. and she's loose. Fuel nozzle, and the actual sheath is here. That's what it looks like inside the engine. You can see some carbon buildup, but you know, there's no erosion. These are really low time engine, and the fuel nozzles have been inspected recently. So fuel nozzle, sheath, gasket, fuel nozzle, transfer tube, fuel nozzle tip. They have these little tiny little fuel filters inside them. They have to be cleaned regularly. But that's pretty much fuel nozzle removal. You have primary and secondary fuel nozzles, and depending on the service bulletin level of the engine, you'll have more or less of primary and secondary. The absolute most complicated part of this whole process, and takes years of experience to do, but the insertion of the insertion tube. It's like, remember those, you know, those things at Cracker Barrel with the two little horseshoes? You had to like get the little ring off. It's similar to that, but way harder. It's really not that hard once you get used to understanding where you're trying to go. It's just pretty much, just think of this as like a corkscrew. Drop it in, never force it. It just, it's going to fall right into place when you find that sweet spot. That's it. You're in. Some people like to leave them loose in there. I like to tighten it down because as I'm got the scope inside, I have something to push against as I'm going around the engine. So here we are about to go into the hot section. There's something in the woods. I swear something's following me. Okay, here we are about to go into the hot section, the money maker, the place where it all happens, the magic kingdom of the PT6. It's where the power of the engine comes from, so here we go. Okay, sir, if you're just going to relax, take a deep breath, and okay, don't fight it, sir. Just don't fight it. Let us, sir, relax, stop pinching. And we're there. You see that circle toward the end. We're just on the other side of the tube, and that just allowed us to get access to kind of a hard to reach portion of the engine. The PT6 airflow kind of goes back and forth, which is one of the actually qualities of the PT6. Is a reverse axial flow. You can see here the CT blades, the trailing edge of one of the vanes, and then the leading edge of one of the vanes. We will go along the leading edge as best we can. Right there you see the small exit duct. And what I do with my borescope is I normally try to catch that edge of that small exit duct right there, the lead of the probe, because it just kind of helps me go all the way around the leading edge. These larger small motors, if that makes sense, the bigger small motors, the -34s, 135s, the bigger vane rings, seem to be a little bit harder to catch and hold on to. Small motor, the smaller of the PT6, the 21s, the 20s, 27s, they've got a different vane ring, and they're a little bit easier to catch. Kind of pitting here is, you know, something to monitor, nothing, no major issue. You can see a really good flat leading edge there. If there's an issue, a spitting or streaking fuel nozzle, you'll start to get some erosion on the leading edge there. So, like I said, I'm going to try to catch this little edge here, and as I do, I'm able to kind of make my way around sometimes. There we go. And as I come around, I'm going to check each vane ring. I'm going to look for cracks, see if I see anything jumping out at me, issues. Now I've just jumped the tracks. I came out of that little lip, and as you see, as I try to go further around, it'll fall off. So you can keep trying with playing with it, you'll get better at it. But here's a good shot of the combustion liner. You can take the probe and kind of twist it with your fingers, and it gets a good shot. You hear that noise in the background? That's actually the little motors that move the tip of the probe around. Motor, I don't know what they actually are, but it's what you use to articulate. Getting a good look at the combustion liner, not seeing any major issues. A little bit of carbon buildup. Looking for cracks, any burns, erosion. So I'll just come back over the small exit duct. You can see straight ahead is the large exit duct. Looking at the PT6 diagram, this will kind of all start to make a little bit more sense. As you can see, this kind of dome right here, it's a big donut inside the engine. It's a large exit duct, and then this is the small exit duct. Basically just routing the air to hit the vane ring. So we'll come back on the other side, and we're going to go down the yellow brick road here. This is the most critical area in my opinion, and I'm sure anybody PT6 experience will say the same. This is the whole purpose of a borescope inspection. You're mainly trying to look at these CT blades. This is where sulfidation occurs. This is where if you're any cracking, you're trying to avoid a catastrophic failure of an engine and to do preventative maintenance. This is a really good clean set of CT blades. Obviously these are really low time. You can see over here on the edge, the squealer tip, there's a minimal distance between the tip of the CT blade and the shroud segment here. A little bit of rub. I'm going to kind of speed through, but just basically 58 CT blades on the small motors. You can go through and count them and make sure you got every one, or you can do like I do, go 360 degrees around, find your probe on the other side and know you've gone all the way. You can spin the compressor and look at each CT blade. I like to go around just to make sure there isn't a vane ring that's burned through. Looking for gaps in the segments. If any of the segments may slip, not a gap, but if the segment slips up, that can cause problems. Anyway, I'm just running along the shroud segment right now, and we should be coming up on our. There you go. There's the probe right there. You see it, big one. We've actually we've gone 360 degrees around the CT disc and the CT blades. This area here is where sulfidation will occur. Okay, now we're going to go through and just do a quick look at the combustion liner and check the fuel nozzles. You're basically just looking for erosion and any type of and corrosion, but looking for any issues with the cooling rings, any cracks. Looking at the other fuel nozzle, the other side there, you can see how they go all the way around the combustion liner. And this is a little sneak I do here. Go into the diffuser tube of the gas generator case. You can, and I have just always been nervous to try it, but you can keep going around this way to get a good look at every side. Be sure that you don't have any FOD on your impeller, and then you can hang a right and go up the impeller and get a good look at a T-bone by sticking your head up a butcher's butt. But wouldn't you rather take the bull's word for it? Wait a minute, that's not it. Wait, it's got to be your bull. But you can see the compressor stator, the third stage compressor stator, and that there is no issues. We're looking for FOD. Okay, we're going to dive into the compressor now. You can see you got your inlet screen, and normally with the older, larger diameter borescopes, you'd have to remove this screen. We're basically just able to slide right through, and then stop looking at the probe because you'll get all turn around backwards. Just basically look at the screen, and You can get a good look at this first stage compressor, except when you get way off. Okay. Good shot of the, you're mainly looking for foreign object damage along the leading edge, and I just use that lock function just to notate there. You know, you get it in the position you want it, you just hit the lock button right here, and it stays in that. As soon as you hit unlock, it goes back to neutral. So anyway, get a good look at the leading edge. You're going to want to go all the way around, which is easy to do with this probe. And there is a good look at the first stage stator. And like I say, we can go all the way around 360. Getting a good look at looking for any foreign object damage, FOD. Looking for any oil streaks, anything that would make you think that you've got a seal that's leaking. I have seen that. A lot of times you'll see corrosion. There's a little bit here on pitting, you know, but you know, this is kind of where corrosion starts here and on the CT blades. That's pretty much it for the compressor. Okay, there's two options for spinning the compressor. You can obviously remove, this is a start generator mounting surface here. This one just has a cover on it for shipping, but start generator goes here. There's a start generator tool which just has a T-handle, and you can spin it that way. A cheap way to do it is to remove the tach generator, but the tach generator drive is the same size as 1/4 inch, and you basically just stick it in there and just give it a light turn. That turns the accessory gearbox, which turns the compressor, and you can spin it in here if there's any rubbing or issues, but that is not a Pratt & Whitney approved technique. The approved technique is the start generator, but some people, I'm not admitting to it in any way, shape, or form, will use this method, kind of a little cheap, quicker, easier way to do, take the tach generator off. Okay, we're going to dive into the power section, the PT stator, PT blades and PT stator, and the back of the CT blades. Going in through the exhaust duct, left hand port, and you can see some nice Pratt stamped blades here with the ink still on them, which is where they come new from the factory. Basically, you can you need to go around and inspect each one, make sure there's basically no cracking, which rarely ever see any issues on the PT blade side, but looking for any kind of a gap on the outside that would match if there's a bigger gap on one side or the other. I've seen that on some prop strike engines. Okay, I've got somebody going to spin the prop shaft for us. Anytime now, there you go. Just a little bitty turn, because you got two sets of reduction gearing, so a little bitty turn makes a big revolution on the blade PT disc here. So whatever you do, don't spin that or let the prop spin windmill whenever you have your borescope stuck through the PT stator. Backside of the CT blades. Oh, there's a good shot of the thermocouple. That's where you get your ITT indications. This is basically the temperature probe. They're all around the PT stator, and you get your temp indications to tell you, basically keep you from going too hot. That's pretty much it for the borescope inspection. We did not dig into the gearbox inspections. I want to say special thanks to the guys at King Air Nation for allowing us to post this on their site. If you don't know King Air Nation, go on kingairnation.com, check them out. Pretty cool, a lot of useful information, and on occasion you'll get a free hat. Pretty cool stuff. This is Carl, Davis Aviation. Thanks for watching the video, and subscribe here, wherever people point whenever they say subscribe.